we already discussed how to solve higher degree differential equation by solvable for p method, where we separate p term and then solve the differential equation, where p is nothing but our p equals to dy by dx. And today we see how to solve the higher degree differential equation by solvable for y, or solvable for x, and clairaut equation form. So first we start about our solvable for y method, where the basic idea is same as like solvable for p, where we have to separate the y term from the equation, and we have to solve the equation. Let us see by taking an example. Here we take x dy by dx square minus 2y dy by dx plus x equals to 0, where dy by dx we can write this term dy by dx as p, so we can write x p square minus 2y p plus x equals to 0. So the basic idea is we have to, here 2x term is there and one y term, so it is better to separate y term. So we write it as xp square plus x equals to 2yp, and then we write it as 2y equals to xp plus a by px. Okay, and further you can write it as y equals to xp by 2 plus a by 2px. Okay, then now differentiate both sides with respect to x, then it becomes dy by dx equals to p by 2 plus x by 2 dp by dx plus a by 2p. Okay, then it becomes a by 2 here x, and it becomes minus 1 by p square dp by dx. Okay, then now dy by dx is nothing but our p, so p here minus p by 2 is there, and then equals to okay, there is another term a by 2p is also there, so we separated and separate dy by dp by dx term one side and other constant term another side. So x by 2 minus x by 2p square dp by dx, and then it becomes p by 2 minus a by 2p equals to x by x p square xp square minus a by 2p square dp by dx, and here also we can write it as p square minus a by 2p equals to x p square minus a by 2p square dp by dx. So here cancel out, 2 cancel out, and 1p is also cancel out, and p square by a also cancel out. Okay, then what we will get, we get x by p, 1 equals to x by p dp by dx, so you can write it as dx by x equals to dp by p. Okay, now integrate both sides, then it becomes ln x equals to ln p, and we can write it as here also we can write it as ln c, there will be ln c. Okay, so then it becomes p equals to cx. Okay, and where p is nothing but our p equals to dy by dx equals to cx. Okay, then y equals to cx square plus some integration constant c dash Okay, so this is our general solution for this differential equation. So now as we see how to solve the higher degree differential equation by solvable for y method. Now let's talk about solvable for solvable for x. Solvable for x. Okay, so here also the basic idea is same. We have to separate x term and then solve the equation similarly like this, and finally we have to integrate it. Okay, let's take an example. So let us take an example where x equals to dy by dx cube minus dy by dx plus 2. So we can write it as x p cube minus p plus 2. So here already x term is separated, so we have to differentiate it with respect to y. Dx by dy equals to 3p square dp by dy minus dp by dy. Okay, and then here 2 is a constant, so it becomes 0. So dx by dy is nothing but our 1 by p. So 1 by p equals to 3p square minus 1 dp by dy. So dy equals to 3p square minus 1 into p dp, and now integrate both sides. So what we will get? We get y equals to 3p cube minus p dp integration equals to 3 by 4 p fourth minus p square by 2 plus some constant c. So this is the solution, and if you put the value of p equals to dy by dx, and then further if you solve it, then you get the exact form of solution in terms of x, and here we get the solution of this differential equation in terms of p. Let's talk about clairaut equation. So clairaut equation clairaut equation is a special type of differential equation where the solution for the p is a constant, and after putting the constant in the equation we get the solution. Okay, so let's take an example. So where y equals to xp minus p square, where p is nothing but our dy by dx. So now if we differentiate both sides with respect to x, then we get dy by dx equals to p plus x dp by dx minus 2p dp by dx. So it p equals to p, dy by dx is p plus x minus 2p dp by dx. So p cancel out, and then we get that x minus 2p dp by dx equals to 0. So it shows that dp by dx, okay, x minus 2p is either 0 or dp by dx is either 0. So as dp by dx, if we take dp by dx equals to 0, then p equals to constant, some constant. Then now putting the value of p here, it's c is a constant, then we get the solution y equals to xc minus c square, where y equals to xc minus. So this is all about to solve higher degree differential equation, and in next we will talk about higher order differential equation and solving of higher order differential equation.